Condensation
Polymerization.
for the nation. Yeah, that's what it is.
Actually for polyesters.
Is it?
Yes.
Oh, should we do that then?
Yeah, let's do that. Okay.
Okay. So polyesters, when you've got an ester, called poly.
Yeah, exactly.
No,
it's
wait
not
a minute.
that, is it?
No, it's when they've got lots of them.
Lots of esters.
Yeah.
Okay, we'll go on to that.
Yeah, so mono is one, so it's one ester, and poly is lots of.
Lots of.
First time, what's an ester? I've forgotten.
Well, we did do a video on this. You should watch it.
Okay, I'll watch it. Oh, it's a good video.
It was. I liked it actually.
Yeah.
I liked the bit with the poly.
The stuff.
Yeah.
Yeah, okay. So an ester is a thing that has a alcohol group and a carboxylic acid group.
And they join together to make a super thing
Yeah,
with an oxygen break.
Yeah, sometimes it smells.
Sometimes it smells like almonds and stuff.
Yeah.
So that's what an ester is. Now we've got polyesters. That implies there's more than one ester joined together.
Yeah, and there's a couple of ways of achieving this.
There is. So if we take a nice carboxylic acid group and a nice alcohol group,
Yeah.
let's take a nice simple one with just a 2 carbon long chain. We've got this OH group on one.
Mhm.
These are just hydrogens.
Okay, I'll do another one, but I'll do the carboxylic acid one.
Yep. This would form an ester at the moment, what I've drawn here, because these are just hydrogens on this side. So at the moment this would just form an ester.
Yeah.
But something rather special is if I put an OH on this side as well as the other side, suddenly we can form polyesters.
Yeah, essentially we can achieve it lots of times. We'll show you how.
Yep.
So first, how do we make one?
Well, we take out a water with a condensation reaction.
Remember that forms a water when you condense windows. Liquid forms, it's great to remember it.
So where do we get the water from? We need 2 hydrogens and an oxygen.
Well, looking at it, you could say there's lots of ways to do it, because we've got an oxygen, OH here, and OH here, so we've got hydrogens here, so it could be there, it could be there. There's lots of places, right?
There is lots of possibles, but there's only one that would actually happen.
Yeah.
We take an OH from the carboxylic acid group. We always take the OH from that side,
Yeah.
never from the alcohol.
And then the H from the alcohol, and it's that oxygen that bonds in the middle.
So we take the hydrogen from the alcohol group. None of these hydrogens attach to the same carbon, because in some scenarios these might not even be hydrogens, they
Yeah,
could be
they do.
halogens or anything. And together they form a nice water molecule, which I drink.
Me too. Yeah. So at the moment that's just an ester, but as Wayne mentioned, it can be a bit more.
Because at either end there's another carboxylic acid group and another alcohol group. So if we were to keep going, we could take an OH from this one and an H from this, and keep going, because there'd be more than one of each molecule, of course. And it would keep on going and going and going and going and going.
Yeah, so you might be able to write that by rubbing out what you would use.
So here I'm just going to write ester, because this here is an ester linkage, this bit.
Yeah, that's an important thing.
We did that in the ester video, but just a reminder, it's still an ester linkage even if it's a polyester.
Yeah, and if you're going to make it into a polyester,
Yeah.
you get rid of these things, that's what we're using.
And the H from this side. So we indicate it by just putting a line to say it could bond to something else. We put it in a box like this,
And
or
then
a dash line, yeah.
N, so how many of these repeat units there are.
So if this was only one, if it's just this, and these didn't actually bond to other things, how many waters would we produce?
Well, only one win, because you only produce one per thing.
Yep. If N was 2, how many would we produce?
2, I think I can put this one in.
I think we can count from there.
Yeah. If, however, you make more waters per repeat unit, obviously there'll be more.
Yeah. So you just got to think about what's going on, but you indicate it with this. Sometimes in exam it might ask you to draw 2 repeat units, in which case rather than stopping here,
Yeah, go on
you'd
one more
repeat the
time.
whole thing again, and then so there'll be another ester linkage here.
Yeah.
And then you put N at the end.
As you said at the beginning, this isn't the only way to create a polyester, so we'll make another way.
Yep, so you could bond the 2 together like this. What if I don't have one carboxylic acid and one alcohol in my shed?
What if you just got loads of an ester in a pot?
Yep, an ester in a pot. Great little we should start a company for that, ester in a pot.
Yeah, that sounds good.
Ester
In
a
every
pot.
home should have an ester in a pot.
Get your ester in a pot.
Yeah, that sounds good. Dogs love it. Kids love it. Yeah.
So we've got a carboxylic acid on one group.
Yep, and an OH on the other side, so an alcohol.
Yep, and these are still just hydrogens.
So that smells fruity.
It does indeed. Now if we had lots of this, it could bond to itself, because you'll notice we can take an OH from here,
Yeah,
and an H from here, just like
Go
normal.
with them then. And like before, it will then form.
Slightly smaller bracket this time.
Yeah.
So it's got this O, and then either a dash line or a solid line. And it's got these 2 hydrogens, 2 and O.
Oh,
don't forget the
I've
O.
got it as well. Wow, I'm terrible. And
Yeah, I do that, don't worry. So then and this should again be a dash line or a solid line.
Yep.
So that is the repeating unit for this. It's bonding to itself over and over again.
Again, forming water.
Every home needs an ester in a pot.
Yeah, and I think With that in mind, we should start the ester in pot business, right?
Yes, let's get a web page and
Okay.
then get some esters in pots.
Alright, and crackers.
Yeah.